So let's look at this problem here. We want to find the equation of the tangent to y equals x squared plus 3 at the point 2, 7. Alright, so this question is asking us, we have some function here. So x squared plus 3, we know what that looks like. You go up 3 units, we have a parabola. And one point on this equation, y equals x squared plus 3, is the point 2, 7. So it would be, I don't know, let's say it was right there. There's the point 2, 7. And what we want to do is we want to find the equation of that tangent. And remember, when we say tangent, we mean tangent line. Okay, in order to find the equation of any line, we need a point and a slope. Well, the point's given, but now we need the slope. So we're going to use our new limit here to help us find that slope. So first let's look at the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So the first thing we need to do is take this equation, or this function, and put it into our limit. So when we have y equals x squared plus 3, that's the same as f of x equals x squared plus 3. That is the same thing. And so this f of x goes in here. Now sometimes the idea of what is this f of x plus delta x, that confuses some students. But when we look at f of x plus delta x, all we need to do is, everywhere there's an x in this equation, we're going to put in x plus delta x. So this is going to equal x plus delta x squared plus 3. So let's put in all our parts. We're going to have the limit as delta x approaches 0 of x plus delta x squared plus 3. So that's this one here. I'll even put a little bracket around that. Minus f of x, which is x squared plus 3. And this is all over delta x. Okay, so let's evaluate this limit. Now, we would always try substitution first, but when we try substitution we divide by 0. And basically, when we're doing these evaluations of this limit, substitution will never work because you always have to divide by 0. So we know we're going to have to use some technique of limits to kind of evaluate this. Now for this one, what we're going to do is we're just going to go ahead and expand things out and see if we simplify to something easier. So what we're going to get over here, I'm going to square that out. So we still have the limit as delta x approaches 0. And we're going to have x squared plus 2x delta x plus delta x squared plus 3. So this part here is just multiplying this binomial out. X plus delta x times x plus delta x. Right? Let me do that. X plus delta x times x plus delta x. So x times x is x squared. Then you get plus x delta x plus x delta x, oops, running out of room here, plus delta x squared. So then you end up with x squared plus 2x delta x plus delta x squared. So that's where that came from. And then we have the 3. All right, then we're going to distribute that negative. So we have a minus x squared minus 3. And this is all over delta x. All right, so then, let's see here, we have the limit as delta x approaches 0. So a couple nice things happen. These x squares cancel out, so those go away. These 3's cancel out, so those go away. So we end up with 2x delta x plus delta x squared all over delta x. All right, now the next thing we're going to do is we're going to factor out a delta x. So this is going to equal the limit as delta x approaches 0 of delta x times 2x plus delta x all over delta x. And now the delta x's cancel out, and so we end up with the limit as delta x approaches 0 of 2x plus delta x. So at this point, because we canceled out the delta x that was in the denominator, we can use substitution again. So this becomes 2x plus 0, which is just 2x. All right, so we have this 2x, and what does this 2x represent? Well, this 2x is an equation that represents the slopes of the tangent line of the function. So let's write this out. So the equation that represents the slope of the tangent lines for y equals x squared plus 3. So the next part is we have to use this equation. So to get the slope of the tangent line, what we need to do is we need to take, well, it says it's 2x, so we need to take the x value, which is 2. So we'll put in 2 times 2, which is 4. So now we have a point, which is 2, 7. We have a slope, which is m equals 4. And so the equation of the tangent line would be y minus 7 equals 4 times x minus 2. Okay? And there's our solution. Okay, so we went through this whole process. We have our little, what we're going to call a limit that helps us find an equation that represents the slopes of tangent lines. We went through the process of evaluating this limit, and we ended up with this equation here, 2x. And so this 2x can be used to find the slopes of x squared plus 3. We then were able to take the x value of our point, 2, because that's what it required. It said 2x, so we put in that x and we got 4, and we were able to find that slope of the tangent line. Okay, now even though this was quite a process, one of the nice things is once we have this process done, this equation represents the slope for any point. So let's say we had this question here. let's find the equation for the tangent to y equals x squared plus 3 at x equals 3. Okay, so if I were to sketch this out, so you go 1, 2, 3, so here is our equation, and then at 3, we want this tangent line, the equation of that tangent line. Okay, so we need two things. We need a point and a slope. Now for this one, we don't have the point. We only have the x value, but it's easy enough to get the point. So we put in y of 3 equals 3 squared plus 3, which is 12. 9 plus 3, which is 12. So our point is 3, 12, and now we need a slope. Well, we already evaluated this limit, so we have the equation that represents the tangent lines. So let's use it. It's 2x. So m of the tangent is going to equal 2. In this case, the x value is 3, so it is 6. So the slope is 6. So that means we can write the equation of the tangent line to be y minus 12 equals 6 times x minus 3. And there it is.